And now I would like to introduce Dr. Maggie Lieu and Dr. Lucia Hackermueller from the School of Physics and Astronomy to tell us all about some of the master's courses we offer and why these are such exciting areas to study. Welcome both. So, just so we get started, could you both give us an overview of your respective master's program? So that would be machine learning in science for Maggie and quantum science and technology for Lucia. And if you can explain us why they are such exciting and rapidly growing areas of study and research today. Yeah.
So you've probably heard like the huge buzz around machine learning, or as some people call it, artificial intelligence. It's pretty much revolutionary right now for how we make discoveries in science. And I think one of the reasons behind that is because of the huge data deluge that we're in. Like our scientific instruments and simulations are just generating so much data. It's just so much that we don't have the capacity to analyze them ourselves with traditional methods. And this is where machine learning becomes really essential. So machine learning is a field of study where you apply algorithms that can analyze your data and perform tasks without giving it explicit instructions, right? And our program, Machine Learning in Science at the University of Nottingham, aims to kind of train the next generation of scientists to harness this power. And I think, I don't even know what to say. It's just a big upcoming kind of area that if you're not going to get involved in, then you're going to miss out, because it's so important with all the data that we need to analyze. In our program, you're not just going to learn about the algorithms, but you'll get the chance to apply them to projects relating to cutting edge research. So this could be anything from, say, analyzing genomic data, to understanding disease mechanisms, to creating AI tools for discovering new materials. There's just so much that you can do. And we really take a kind of hands-on approach to this. We get our students involved in research projects, and this gives them kind of a competitive advantage in the job market. We also give them so many transferable skills, things like data analysis, programming, problem solving, so they can go out and work in other fields too. I think the demand for machine learning in science is just growing exponentially. It's everywhere, not just academia, industry, governments, everywhere.
Great. And Lucia, if you had to answer for quantum science and technology.
So the year 2025 is actually the International Year of Quantum Science and Technology. And that is for a reason, because we all think that it will be very important for the future of the world, basically. So this is really innovative research and technology that will enable us in the very near future to do computations that we have not been able to do ever before, to do them faster than ever before with quantum computers. And the other very interesting area is sensing, to create sensors that are sensible and have such a precision that we can now go into areas that we have not been able to explore before, and that can be precision in gravity, that can be understanding what actually is underneath our floor, how can we find better resources, how can we do better mapping, how can we do better navigation, how can we do better timing. All of that is opened to us through quantum technology. So we are really at the moment in time where this whole area is on the brink of really exploding, of really being applicable to our everyday world. So quantum computers are not really there yet, but almost. Companies, huge companies like Microsoft, Google, Intel, they are all working on their programs to bring these to the societies. And quantum sensing is working perfectly fine in laboratories, and is now at the stage where it is taken out of labs and we bring it into the field. And also there, some research is still necessary to make them more robust, but this is something that we actively work with. And that brings me to Nottingham. So Nottingham is outstanding led through its research. So one exciting area of quantum technologies is using quantum technologies for brain imaging that has been developed in Nottingham, and that, for example, makes it possible to apply this type of imaging now in unusual situations, like for children who move around or to detect something quickly. So our program is driven by the exciting research that we do, and we also give the students will have the opportunity to work with researchers on programs that are linked to that research and to be involved in that exciting work.
That's great. You have already answered about how Nottingham can be a standout choice for the students. So staying with you, Lucia, if you could also tell us about how does the curriculum at Nottingham prepares the students for the future, particularly in terms of addressing the global needs of the skilled graduates in these fields, if you can comment on that.
So for the quantum and technology course, the course has two pathways. That is a theoretical pathway and a quantum technology pathway, a more hands-on practical pathway. And that is a demand that has come from industry, because what industry currently needs are people who can work in both areas or who can talk to experimentalists who can talk to theorists and the other way around, so have an understanding. So our course, therefore, will prepare the students in an excellent way to thrive in the upcoming quantum science and technology industry and research.
Great. So Maggie, if I could ask you, like looking ahead, what are the emerging trends for or growing areas in machine learning and quantum technology that students would be excited about, and how is Nottingham positioned to equip graduates to lead in these areas?
Great question. Well, as I said, machine learning, that field is exploding, and quantum technology, as we heard from Lucia, is just beginning. I think one exciting area is combining the two of them, machine learning and quantum computing. So quantum computers, they have the potential to solve some of the problems that even with the most powerful classical computers, you wouldn't be able to solve. So combining that with machine learning, well, you could make leading breakthroughs in things like drug discovery and optimizing problems and all sorts of things. So I think that's super exciting. Another trend that I'm excited about is the development of explainable AI. So machine learning algorithms, as they get more complex, we need to know more than ever, like, why are they giving those answers that they're predicting, right? So explainable AI is looking at creating models that are transparent, which it's really important in science because we want to trust and be able to interpret these models. And I think the University of Nottingham is like perfectly equipped to do this. We're well positioned to equip our graduates to lead in areas of machine learning and quantum AI because we have world-class researchers here. We're working at the forefront of these areas. I also think like the way that we tend to do research-focused, hands-on kind of projects really ties into it. It prepares our students not only with the knowledge, but also with the skills to succeed in their future for any challenges and opportunities that come their way. We're also very committed to providing our students with the state-of-the-art resources. So technologies like GPUs, high-performance computing things, facilities, that makes us highly desirable and super important in the fields of machine learning and quantum technologies.
Thank you for these amazing insights. I think it gives a lot of perspective to students who are looking to study these courses at Nottingham.